So, looking at this question 6, you have to simplify parentheses in which minus 3 y raised to power 3 inside the parentheses r raised to power minus 1 multiplied by parentheses minus 6 y raised to power 4 everything raised to power 3. So, how can you simplify this kind of question? That is the question you ask yourself. The first thing is that what? You introduce, I've been explaining product law. So you use product law to simplify this, and you can deduce that um we split the value inside the parentheses, that is minus 3 y raised to power 3 everything raised to power minus 1. So I splitted it into their respective terms, so in which we are having numbers and letters. So and then using a product law, you can see that because everything is raised to power minus 1, so that is why you are having in this place, you have what? You have minus 3 raised to power minus 1 multiplied by y raised to power 3 all raised to power minus 1 multiplied by minus 6 raised to power 3, still product law. We are using product law multiplied by y raised to power 4 everything raised to power 3. So after that again, you still do what? So you can see that we have in the next line, we have minus 3 raised to power minus 1 multiplied by y inside the parentheses raised to power minus 1 times 3 multiplied by minus 6 inside parentheses all raised to power 3 multiplied by y all raised to power 4 multiplied by 3. So you will observe that now in that y letter, you can observe that we've already used product law, in which we are now bringing what is inside that parenthesis, we are multiplying it by the power outside the parenthesis. That was why you are seeing that y as what? That's why you can see that y as what? Minus 1 y raised to power minus 1 multiplied by 3, and the other y, which is y, let me zoom in, which is y raised to power 4 multiplied by 3. So you can see that. So and the next line, so after using product law, eventually you see that that minus 3 raised to power minus 1, I said it is called negative. Anything raised to power minus 1 is called negative index, and which is going to take you back to fraction format. So that's why you are saying that minus 3 raised to power minus 1 to be what? Minus 1 over 3 multiplied by, now you observe that I've already used what can I call it, multiplication law. Via what? Via adding the respective index of that y letter together. You can see at the previous line, we have y raised to power minus 3, and the second y raised to power minus 12, and eventually in the next line we have what? Y raised to power minus 3 plus 12. So multiplied by minus 216. So if you express this, record that minus times minus is plus. So that is why you're having 108 y raised to power 9, because minus 3 plus 12 is 9. So that is why y is what? Is raised to power 9. And that is the final answer for that question 6 under product law. So now you can, let me just zoom the product law. Let me zoom it out to check through. You can check through. Let me zoom in a little bit to have better view. So see, this is all about product law. So all about product law. So actually in any question given, there is tendency that we will be applying almost all the laws in the aspect of indices. So now we are moving to fraction law. So this law can be applied either in form of what? When you are having the index being expressed as fraction, so because that's fraction law, so we call it fractional index. So you can see that a is raised to power what? 1 over m, and in which can write back as what? M square root a. Shall you get now? Or if you are given in term of two different integers, you get what I'm saying now? Two different integers. Yeah, I think that is a better way to say it. Or actually, let's say natural number. It can be expressed as decimal to some time, then you convert to fraction. Yeah. So that is rational number to say. So now you can see, or when a raised to power n divided by m, the other way around you can write it is what is a raised to power n. Let me zoom in everything inside the square root of m. So or you first find the square root of a with respect to m, then you multiply it with raised to power n. So you have better understanding of this when we begin to solve samples under this law. So let's look at we have to simplify 100 raised to power half. So automatically whenever anything is raised to power half, we call it square root. So you get now. So you have been acquainted with the word square root of 25, square root of 36. So that is telling you that 36 raised to power half means the same thing. So you observe that the index of this question is fraction. Thus, fractional law will be applied. So because we can call the fraction the index, you can call this fractional index. So whenever you have an index given in form of fractional index, you are going to be using fractional law. Show you again now. And the law is what is this. These are the possible way you can have the question. They can ask you the question. So thus 100 raised to power half also means what? Square root of 100. You can see now the m will be outside this, will be between the square root. So we call square root, that is 2. So if it is 3, call it cube root, and then probably 4, maybe quad root, I don't know. So and square root of 100 is what? Is 10. So all the same. So the second example is you have to simplify 1 over 4 inside parentheses 0 raised to power minus half. I told you this is a negative index and a fractional index. So solution, one is a negative index, you first word you change it to fraction, that is 1 over what? 1 over inside the parentheses 1 over 4 all raised to power 1 over 2. So the next line is that what? Recall 1 over 2 means square root. So that is why you're having it to change to 1 over square root of 1 over 4, and the square root of 1 over 4 is what? Is 1 over 2. That is why you're having it here, that's what? Is 1 over 2. So that is 1 all over 1 over 2, which also equals to what? 1 divided by 1 over 2, and eventually the answer will be what? 2. So that is the simplification of that stuff, and you can actually find, okay, that is the right approach actually. And the third example is 8 raised to power 1 over 3. It's very simple. Recall I've said it earlier that there's something we call cube root. So this is cube root. So 8 raised to power 1 over 3. If you find the cube root of 8, is actually what? It's actually 2. So and this is another way you can solve it. You change that 8 to index. Let's say 2 raised to power 3 multiplied by the power outside, that is 1 over 3. Applying product rule, eventually the index inside the parentheses will go outside. So that is why you're having 2 raised to power 1 over 3 multiplied by 3. So and eventually 1 over 3 multiplied by 3 is 1. That is why it is what? 2 raised to power 1, which is what? 2. All the same. Any approach you want, just have the basic understanding of where and how you can apply the laws. Sure you get it now. So question 4, we have to simplify. We have to simplify inside the parentheses 0.027 all raised to power minus 1 over 3. So the same approach. So we eventually it leads to what? 27. Recall that 0.027 is actually the same thing as 27 over 1000. All raised to power what? Minus 1 over 3. So if you change it to index form, that is 3 raised to power 3. Recall 27 also equals to 3 raised to power 3, and 1000 also equals to 10 over 3. So that was why you have inside that parenthesis in the next implication is what? Is that is 3 raised to power 3 divided by 10 raised to power 3. Everything all raised to power minus 1 over 3, because it's still inside the parentheses. So the next approach is what? Is you bring out the common power. Yeah. So that was why we are having now only 3 over 10 inside the parentheses, and everything raised to power 3 still multiplied by the last index outside of multiplied by minus 1 over 3, because it's the last power there. So the code I've said power index exponent can be used, they are equivalent, so they are the same thing. So in which, because that outside power is negative, that is minus 1, is going to be what? Is going to be is eventually going to change the fraction. And that is why we're having what? 1 all over inside parenthesis 3 over 10 all raised to power 3 close everything raised to power 1 over 3. So applying product through, we can see that we've brought out that 3 inside the parentheses. It's now multiplying it with the 3 outside the parenthesis. So that is why we are having what? We are having 1 all over inside parenthesis 3 over 10 raised to power 1 over 3 multiplied by 3. So 1 divided by 3 over 10 is actually what? Is, you can express it in this way, which is what? 1 times 10 over 3, which is what? 10 over 3. So that is the final answer. And another approach is this, where you are saying, recall is a cube root. So firstly, we change it to what? We change it to fraction because it's negative index, so, and also a fractional index. So after that, we just use it directly because 1 over 3 is a cube root. So that is 1 over 3. That is 1 over cube root of 0.027. And what is the cube root? You can change it. That is why you are saying 27 over 1000. So what is the cube root of 27 over 1000? Is 3 over 10, which also equivalent to what? 10 over 3. That is 1 divided by 3 over 10, which is 10 over 3. So the next line is what? We have to simplify. Simplify also what? 216, everything raised to power 1 over 3 inside the parentheses, everything also raised to power 2. So just follow the same procedure. We recall 1 over 3 is a cube root. So that is why you're having that 2 over 3 inside the cube root. It's inside the cube root. So what is the cube root of 216 is what? Is 6. That is 6 raised to power 2. And that is why it's 36. So, or you can use index to solve. You can show how many numbers of things you are going to multiply with each other. That's going to give you 2 answers, and which is, so yeah, you have to simplify inside parentheses 0 raised to power 3 multiplied by. So if you are given this kind of question, how are you going to simplify it? Inside parentheses, we are having a raised to power 3 multiplied by 125, everything all raised to power 2 over 3. 2 over 3 is what? Is a fractional index. So you are going to apply what? Fractional law. So that's why you are seeing the implication that what? So you can see that I've used product law at first instance. I'm still going to use product law. So via splitting, you can see that the expression of inside the parentheses a raised to power 3 multiplied by 125 all raised to power 2 over 3 has now changed to what? Inside the parentheses a raised to power 3 multiplied by 2 over 3 multiplied by a raised to power 3 inside the parentheses all raised to power 2 over 3. And you see that it's all raised to power 2 over 3. So that index, fractional index that is outside the parentheses, is now multiplying everything inside the what? Parentheses. So, and also what? Multiplied by inside the parentheses now 125 all raised to what? 2 over 3. So you can see simplify further. So now you observe that for a, I've taken out the 3 inside that parentheses because initially it was a raised to power 3. Now it's now what? A is now only a inside the parentheses. Everything now raised to what? 3 multiplied by 2 over 3 multiplied by. Now you can observe that 125 is now has now been changed to index. That is 5 raised to power 3. So everything multiplied by what? 2 raised to power 3. So solving it mathematically now, you see that whenever already has been raised to 3 multiplied by 2 over 3. So simplifying it, we have 2. That was why we have what? A raised to power 2 multiplied by. And for that 5 aspect too, we've taken out the 5 inside the parentheses, the power, the index inside the inside the parenthesis, we've taken it outside and it's now multiplying the outside index. So that is why we have 3 multiplied by 2 over 3. And also what is the solution is 5 raised to power 2. So you will see that we're having 5 raised to power 2 multiplied by a raised to power 2, which the final answer is what is 25 a raised to power 2. So, and you can solve it in another way around. You call 2 over 3 also means 1 over 3 multiplied by 2. So if you solve it like that, you have square root of 1 over 25 a raised to power 3, everything raised to power 2. So we have what? We have inside parentheses 5a raised to power 2, and which is what? 25a squared. That is fractional law. So and another question is you are asked to simplify 3 raised to power minus 1 over 6 multiplied by 27 raised to power 1 over 3 divided by 9 divided by 9 all raised to power 1 over 2. So the simplification is this. Now the one that can be changed to index, you can see 27 has been changed to index. So now the expression is now 3 raised to power minus 1 over 6 multiplied by 3 raised to power 3, because 27 also means 3 raised to power 3, all raised to what? 1 over 3 divided by 9 also means 3 raised to power 2. So that is why we have inside that parenthesis 3 raised to power 2 all raised to power 1 over 2. So now applying product law, you can see that here I've applied product law. So and it's now what is 3 raised to power minus 1 over 6 multiplied by, I can deduce that 3 inside that parenthesis have been taken out. So because the initial expression is 3 raised to power 3 inside the parenthesis, 0 raised to power 1 over 3 has now changed to what? 3 is now only inside the parenthesis, or multiplied by what? 3 multiplied by 4 over 3. So divided by the same thing has been done to what? Has been done to the one that inside the parenthesis is 3 over 2, which has now changed to only 3 inside the parenthesis, and everything raised to power what? 2 multiplied by 1 over 2. So with that, can simplify for that. We are now having what? We are now having so if you solve it mathematically, we are now left with what? 3 raised to power minus 1 over 6 multiplied by 3 raised to power 4 divided by 3. I told you anything raised to power 1 is we still retain that digit, that figure or that value. So now applying Bodmer's rule and then start from the left hand side. Actually you can just apply it directly. So actually I apply Bodmer's rule, but you can use it everything. Wherever you see multiplication you add, and whenever you see division you subtract or you deduct. So but applying Bodmer's rule based on what I've stated before the next line. So that was why we're having what? Applying Bodmer's rule and start from the left hand side, that is LHS. So you will see that we are now having, firstly I do the multiplication aspect because I'm starting from the left hand side. So that is why you will see that the expression has now changed to what? 3 raised to power minus 1 over 6 plus 4 divided by 3. So if you solve it mathematically, we now have 3 raised to power 23 over 6 divided by 3. So now you apply division law. The first law we apply is multiplication law. So after that, division law now, because it's division that is existing between. So everything is now 3 raised to power 23 all over 6 minus 1. So if we simplify, the final answer will be 3 raised to power 17 all over 6. So that is the final answer. Let me just zoom out so you can have better view of this and this. Don't worry, I'm going to zoom out everything later after I'm through with the explanation. So the next line is yeah, we are now in for that fractional index. Before we go to general, before I solve general problem, different questions that we are going to, there's tendencies of applying all the laws given above. So applying Bodmer's rule, actually I have to simplify 6s squared multiplied by 3 raised to power minus 1 multiplied by s raised to power minus 2 divided by 5 raised to power minus 1x. So how can you solve this? Firstly, you apply Bodmer's rule, start from the left hand side and collect the allied base. Yeah, I've explained what the base is. So solution. Now I said collect the what? Collect the like terms. So that was why you will see that 6 is now being multiplied by what? 3 raised to power minus 1, and the x as the base has been collected together. So that was why you are having inside another parenthesis x square multiplied by x minus 3, using square brace to enclose everything, divided by, recall, Bodmer's rule and collecting the like term. And I started from multiplication before jumping to division. So that was why I used square brace to embrace that expression. Everything divided by 5 raised to the power minus 1x. So the next line is what? You can see that I told you whenever any base is being raised to negative index, we call it negative index. It will give you fraction. So that was why 3 raised to power minus 1 has changed to what? 1 over 3. So 6 multiplied by 1 over 3 inside the particular parenthesis, and applying a multiplication law, you can see that x has now been what? Has now been changed to x raised to 2 minus 3. There we apply multiplication law, all divided by, everything is in a square brace. Square brace, divided by 5 raised to power minus 1x. So in the next line, you see that 6 multiplied by 1 over 3 is actually 2, and x raised to 2 minus 3 is what? It will be what? Is x raised to power minus 1. So that is why we are seeing it in the parentheses to be what? 2x raised to power minus 1, all divided by what? All divided by 5 raised to power minus 1x. So now you still do the same thing. You do what? You collect the like times, follow Bodmer's rule. Actually, we are left in division alone now, so you don't need to follow Bodmer's rule, but you collect the like term. So collecting the like terms, you can see that now, or you can express it that 2x raised to power minus 1 is actually what? 2 multiplied by 1 over x, which is going to give you what? This is going to give you 2 over x divided by, and also 5 raised to power minus 1 multiplied by x is going to give you what? S all over 5. So that's why you're having 2 over x divided by x over 5. And if you express it in multiplication from, that will be 2 over x multiplied by 5 over x. That is 10 all over s squared. And the final answer is what? 10 multiplied by x raised to power minus 2. So recall 1 over s squared can also be respect because it's also a negative index. That's what? X raised to power minus 2. And the final answer is what? Is that. So let me zoom out for you to have a better view of what I've been explaining. So you can zoom it inside the video. Yeah, so that is the solution for question 8. And so now let's look at some various problems. So let us solve some problems that all this law will be applied. So the first question is what? The first question is simplify 3 raised to power 2n minus 1 divided by 81n multiplied by n raised to power 3n plus 1. So how can you do this? This is the solution here. So this is the solution here. So the first thing is that you look at the big number if actually it's not in the prime number, because the last expression we can do is being expressed in what? In prime number. You understand the word prime number? Prime numbers are numbers that one and is that can divide himself and one only. So that is your focus. That is what will be your base, because it's a factor. So do you get it now? So that is why we are changing that 81 raised to power n to be what? 3 raised to power 4, everything raised to power n. And the same thing to 9. 9 is also what? 3 raised to power 2, everything raised to 3n plus 1. So after that, once they are now having constant base, you apply product law before applying multiplication law. So applying product law, you see that I did not touch that 3 raised to power 2n minus 1 divided by 3 raised to power 4n multiplied by 3 raised to power 2, everything inside parentheses 3n plus 1. So applying product law, you will see that in the next line we do not have what? See that I've brought out the 4 inside that parenthesis, which is 3 raised to power 4n. Now it's now what? 3 raised to power 4n. And then the same thing too. So we now have we see that we are having now 3 raised to power 2n minus 1 divided by 3 raised to power 4n multiplied by 3 raised to power 6n plus 2. And eventually you can apply you can use Bodmer's rule, and also you can apply it directly. Yeah, so that is why me here I apply directly. I apply both division and multiplication law. So that's why you are seeing every once they have common base, which is 3. So that is why everything is being subtracted and being added together. So that is why you have 3 raised to power 2n minus 1 minus 4n plus 6n plus 2 with respect to 2. Sign in between the what? Different base. So you get now in between the base. So and you add up mathematically, you have what? We have 4n plus 1. So that is the final answer there. So you can express further actually, but you don't need to complicate it. Just leave it that way. And the second example, let me zoom out again. So that is the solution for that question 1. And question 2, do what? Follow the same procedure. You first split them, separate them, the one with power of n and the one with natural number power. So 2n plus 2 has been changed to what? Inside the parentheses has now been what? 2 raised to power n multiplied by 2 raised to power 2, which is equivalent to 2 raised to power n plus 2. So and we have minus 2n plus 12, and we see that 2 raised to power n minus 1 has been changed to 2 raised to power n divided by 2. It's also the same thing. And the next line, we see that now 2 raised to power 2 is 4. That is why you are having 4 words. 4 is being multiplied by 2 raised to power n minus 2n. There's nothing you cannot, there's no expression you can give to that. It's still the same thing. So now 2n divided by 2 is now 2 raised to power n over 2. So plus, so record here is 12 outside the before the parentheses. So and recall 12 divided by 2 will be 6. That is why you will be saying it in the next line that 12, that is 4 inside the parentheses, 2 raised to power n minus 2 raised to power n plus what? 6 inside the parentheses, 2 raised to power n. You will observe that 2 raised to power n is constant, so you factorize it out. So that is why we are factorizing it here. That is why you are saying 2 raised to power n outside. And what is left is what? 4 minus 1 plus 6. And the expression is what? Is 4 minus 1 plus 6 is 9. So you bring out that 9. So that is why you're having the final answer to be what? 9 inside the parentheses is 2 raised to power n. So that is the final answer there. So you just apply same principle, the same steps that we've been applying to solve all the questions. So that is the solution for question 3. So and you have to simplify k raised to power n plus 2 multiplied by k raised to power 3 minus 2n, all divided by what? K raised to power n, k raised to power 5 plus 2n. So you apply the same thing. So once they have in common base actually, so you first at the numerator you apply multiplication law. So that's why you are saying that to be what? K all raised to power n plus 2 plus 3 minus 2n, all divided by k raised to power 5 plus 2n. You solve stepwisely. So now this expression is now what? So you are having what? K raised to power n, k raised to power minus n plus 5, which is also the same thing as k raised to power 5 minus n, all the same, divided by k raised to power 5 plus 2n. So having this, record that is division law. So using division law now, that's why you are saying that it's now what? K raised to power n plus 5 minus 5 plus inside parentheses minus inside parentheses 5 plus 2n. So simplifying this, you have what? You have k raised to power n plus 5 minus 5 minus 2n. So which eventually will give you what? K raised to power minus 3n. So because it's a negative index, so it's definitely going to be a fraction. So the final answer is now what? 1 over k raised to power 3n. So that is it. So yeah, this is an equation. Find k from this equation. This is question 4. We have to find k from this equation so that 27 multiplied by 64 equals 2 raised to power 3 multiplied by 6 raised to power k. So, and the simplification is this. Recall that 2 raised to power 3 is 8. So definitely that will be equals to what? 27 multiplied by 64 equals to 8 multiplied by 6 raised to power k. So you divide both sides by what? By 8. So that will be 27 multiplied by 64 all divided by 8. And eventually it will be 27 multiplied by 8, which is equal to 6 raised to power k, because 64 divided by 8 is what? Is 8. So Then you can now change that what to the indices format. So we now have 27 is now what is now 3 raised to power 3 multiplied by 8 is now what 2 raised to power 3. Everything equals to what 6 raised to power k. So and you can bring that constant index that is constant to 3 and 2. So that was why you're having in the next the one after that implication. That is why it's being implied to what everything inside parentheses 3 multiplied by 2 all raised to power 3 equals 6 raised to power k. Because 3 multiplied by 2 inside that parentheses is what is 6. So that is why 6 raised to power 3 equals 6 raised to power k. Comparing the same base, definitely your k will be what? K will be 3. So it's question 5. So this is the solution to question 5. Cannot explain everything, just follow the steps you will learn from work we've done so far. So follow this procedure. So you see, this is question 6. Solution to question 6. So here you have to find m raised to power m. So this is solution to this. So this is solution to question 8. And question 9, which is the last one, that is the solution to it. So I cannot explain everything, but the solution is well explained if you follow it and look at it. It's been solved stepwisely. So just check through the solution. And the next one we are going to be talking about working on indices, indica equations when like the one I solve here is also called indica equation. Where is the question? This one, so you can also call it indica equation. So when you are comparing, yeah, where is the question I solve? Yeah, like this one, question 4, you can call it indica equation. So something like this or more complex of it will be done in the next class regarding this topic. So let me start from the end and head at the beginning. So look at it, you can zoom in when you are doing your own, when you are watching the video, it will be more clearer. So to be more clear, so check through. This is so this is the solution. So you can just zoom in to have better view of it, to be clearer. So this is the solution. This is what I've been explaining since. So diffusion law, multiplication law. So and that is all about the class of indices. So see you in the next class. God bless.